So how many of you have glasses here today? Put up your hand. Or contacts. Glasses or contacts. Okay? So at least half of us, okay, have glasses or contacts of some sort. We just got finished talking about lenses, and one of the big reasons that we have lenses today is to help defects in vision. And the eye is a very special part of the human body. It's a very, very complicated machine. It was designed incredibly complex, and it's something that we're going to study a little bit, the parts of the eye today. And where we're going to get to real shortly is defects in vision and how that is corrected by lenses. So this is kind of how, the application of our study in lenses. Now, I don't know how many of you know what kind of lenses you have, whether they're converging or diverging. Do any of you know the power of your lenses? Yeah, like negative 1.5, okay. Does anybody else know the power of their lenses, glasses? Okay. 0.5, okay, that would be a plus 0.5, positive 0.5, okay. Okay, probably, you don't know. All right, we're going to find out exactly what those numbers mean too. That's coming up as well, okay. But anyways, let me just erase this. I'm going to have to make this just a little bit bigger here for you to see. But on your blank paper, I'm going to get you to write down sort of fill in some of these blanks, okay. So, parts of the eye here, okay. Well, where should we start? Well, this part right here, okay, as soon as we're talking about lenses, glass and plastic lenses, let's talk about the lens that we all have in our eyes. So this is the lens right here. This won't match up exactly with your diagram, but you can find out where this piece is, and it's number 5 there, okay, is the lens. So yeah, on page 501, is the diagram that is exactly the same as your sheet, but just for projection purposes, I'll just use this one. So this is the lens right here. Now, the lens is shaped in a certain way as to refract light coming into our eye, okay? And there is a lens that refracts light, but there's also something called the cornea right here. This is the cornea, the transparent part of the eye that kind of protrudes from the lens and this area of the eye here, the cornea. Now, if you're very careful, you might have done this before, but take your 2 fingers, all right? Now let me just put this on here. Okay, where is it? I'm going to put on. Okay, get this whole thing going. Okay, so here we are. So take your 2 fingers like this, okay, and very carefully, I want you to lightly close your eye, like this. Lightly close your eye. I want you to put your 2 fingers on top of your eye, and if you kind of look left and look right, you can feel a lump on your eyeball moving back and forth. Okay, press very lightly, don't hurt yourself, but you can feel, and even if you open up your one eye, look left and right, up and down, can you feel that lump on your eyeball there? All right, so this is what we're talking about. We're talking about the cornea right here. So I'm just going to move that off to the side. We're talking about that cornea right there. Okay. What else? Okay, this right here. Okay, these are the suspensory ligaments. Okay, suspensory ligaments, and these little ligaments are what are attached to your lens. And when these muscles, okay, there's muscles that are associated with this. When the muscles contract, and I think on your diagram, do you have ciliary muscles here as well? Okay, so there are ciliary muscles that are attached to the suspensory ligaments. So muscles attached to ligaments attached to whatever they're moving. In this case, the lens. In other parts of your body, muscles attached to ligaments which attach to bone. The muscles move, and the ligaments sort of like are just kind of holding, they're grabbing onto the bone, they're grabbing onto the muscle, and that sort of thing. And so in this case, these ligaments attach to the lens. Now the lens gets stretched, and when you have to look far away, all right, the lens thins out quite a bit. When you have to look close up at an object that's really close versus far away, the lens kind of gets fatter. And so these ligaments are attached to the lens. The muscles actually change the shape of the lens in your eye. And so that accounts for the different refraction. Now watch this. From a far away object, if the lens is very narrow, it's going to refract the light very little, right? But if the object is close up, okay, let me just erase that and erase this too. If the object is very close, okay, your lens has to refract the light quite a bit. You see how this angle right here is smaller, or there's more refraction, and so your lens has to adjust. Now, if your lens can't adjust very well, or if the shape of your eyeball, the distance from here to here, or something like that, or the shape of your cornea is altered, and this combination of cornea, lens, space, shape of your eyeball, back to the retina here, if all that combination doesn't work just right, you're going to have some vision problems. And so the light that's refracting is not going to refract back to the proper spot, okay? Or it's not going to form a sharp image. So without your glasses, those of you that have glasses, I don't know what the issue is, but it could be the combination of your cornea shape, your lens action here, and even the shape of your eyeball. All of those put together, might contribute to decrease in the sharp images in your eye. So that's why you need some glasses help. So we'll talk about that later. Okay, what's next? What else? The iris. Okay, so this little part right here is the iris. Now, in the diagram, all right, this is a two-dimensional cross-section of your eye, so it looks like, it's not all one piece. But in your eyeball, of course, it's the colored part of your eye, okay, the iris. And the pupil is actually not a black disc in your eye. It's not actually something that you can remove and say, oh, here's my pupil on the table. The pupil is just an open space, and you probably know this already. It's black because there's no light bouncing off it. All the light that's going through your pupil is going back into the back of your eye and being absorbed. So the pupil is a black disc, but it's not actually a disc, it's just an opening. And I don't know if you guys have ever done this before, but we're going to do a little activity. What I want you to do is just with someone nearby you, okay, just kind of turn to someone nearby you. And what you're going to do for this little activity is you're going to stare, and you're going to look at the person in the eye, okay? You might want to remove glasses because this might be you got to see your pupils, okay? So one at a time is what we're going to do. Okay, now you're gonna need to get kind of close if you're going to actually notice this. Not too close, I'm talking like, like a foot or something. But so what you're going to do is this, ready? One of you is going to go first, so decide who's going to go first. And that person is going to close their eyes and cover their face, cover their eyes, so that it's really, really, really dark, okay? So that you can't see anything. And you're going to do that for about 20 seconds, okay? So right now, go ahead and start. Cover your eyes. One of you cover your eyes. Now what the other person is going to do is going to get pretty close to the other person's face, okay? Don't hit them or anything. What we're going to do, on the count of 3, when I say open up your eyes, the person that has their eyes covered right now, you are going to, don't do it yet, but you're going to quickly remove your hands and open your eyes as wide as possible and stare straight ahead. Do not try and look at the other person in the eye, okay? Just don't do it yet. Don't do it yet. Okay, quiet. Quiet, Daniel, quiet. When I say go, the person whose eyes is not covered, you need to look at their pupils because it's going to happen in a fraction of a second. You're going to see the pupil change size really quickly as they adapt to the light. Okay? So are you ready? On the count of 3, those of you covering your face, covering your eyes, take a look. Are you ready? 1, 2, 3, uncover. Oh, wow. Okay, now the other person. Do the other person so that the other person can see. Cover your eyes, close your eyes, cover your face. All right, so what's happening in that? Just once again, everybody settle down. What's happening once again with that little activity, okay? As I said, when your eyes are covered, your eyes are saying, hey, where's all the light? I need light to be able to process things around me. And so your pupil is super huge, okay? Because your pupil, your iris and everything is opening right up to allow maximum light in. As soon as you quickly uncover your eyes and open your eyes up, all that light floods in and your eye goes, oh my goodness, now we've got too much. So now I gotta cramp that space closed to restrict the light that's coming in because this is way too much right now. So that's what's happening. Your pupil seems large, and your pupil then kind of shrinks right down when all that light comes in. So you can see how your pupil, and again I talk about it like it's an actual real thing, but remember it's just a space. It's just an empty space. You see right back into into your eyeball, back to your retina. So back here, let's talk about this. Where the light falls and it starts to be processed, what you see is on the retina. R-E-T-I-N-A, retina. Okay? Now there are parts behind the retina that we should know about, and the choroid is right behind the retina, and another layer beyond that is called the sclerotic. Okay, the sclerotic, S-C-L-E-R-O-T-I-C, sclerotic. Your eyeball is not filled with air. If you guys knew that, your eyeball is squishy. It's filled with a jelly-like substance called the vitreous humor. It's awesome. Okay, jelly-like substance. Yes, is that awesome? Okay, it's not actually jelly. What's closest it's like to? I don't know. It's just kind of it's just kind of a viscous liquid. Blood vessels kind of feed your eye tissues, and so they're on your eyeball there, and they kind of go throughout. The vitreous humor is sort of the viscous liquid that fills your eyeball to give it its shape. Probably a little bit, yeah. I don't think much though. I think the blood is sort of on the outside. Again, that's a good question. But okay, guys, shh. You're focused up here now, please. Vitreous humor. Now, inside between your lens and your cornea is called the aqueous humor. So this substance in here is the aqueous humor. Vitreous, aqueous. Okay. Now, aqueous is the root form for water. So this is it's a more watery. This is a bit thicker. It's got all sorts of different things in it. This one's a bit more watery. All right, so what else do we need here? Iris, lens, got that, sclerotic. Okay, so the optic disc, okay? So this is the space right behind your retina, and this optic disc actually, and where the optic nerve attaches, so the disc and the nerve, this is where all of the signal from your retina gets funneled and sent to your brain. So this is the nerve, the optic nerve that sends all of this data to your brain. And this optic disc right here is where your blind spot is, because it doesn't receive any light to process. This is why you have a blind spot. It's where the optic nerve is connected to the back of your retina. All right, we're going to talk about your blind spot. Can we wait? Okay. Now, when we talk about a blind spot when you're driving, now many of you have your license or have had a lot of experience driving if you don't have it yet. Anyways, your blind spot when you're driving, is that one spot that your mirror you can't see, kind of right close to your car, kind of off the back fender there, and that's why you do a shoulder check, right? Quick shoulder check so you can see what's in your blind spot. See if there's a small car there, something that you've missed in your mirrors, okay? So there is a blind spot in your eye as well, and I'm going to show you how you can kind of see that. So again, what we're going to do is we're on your piece of paper. I want you to draw this, okay? I want you to draw this on your paper, okay? Here we go again. Now, I want you to draw, okay, 2 small dots on your paper. Doesn't matter how far apart they are. I mean, I've got mine 5, 6, 7 centimeters apart. 2 small dots like this. Don't make them too big. They got to be pretty small. All right? And what you're going to do, okay, so I'm going to look at this, like this. What you're going to do is you're going to cover one eye. So I'm going to cover my right eye, and I am going to look at one of the dots, okay? Now, what you're going to do, and we'll find out which dot you should be looking at, okay? But you have to have your dots like this, okay, side to side, not up and down like that. It's not going to work. So side to side. And what you're going to do, start looking at one of the dots, okay? And now, your brain is in the middle of your head, right? And your eyes are kind of on the outside. So I want you to think about where this blind spot might be. Which side of the back of your eyeball might your blind spot be on? Okay, think about that. But what you do, here's what you do. Pick one dot, and then it will work for some of you and not for the others, and we'll figure out which dot we should have looked at and where the optic disc is. So look at one of the dots, focus on it, do not look at the other dot, just look at one of the dots, and slowly move the paper in until in your periphery you cannot see the other dot anymore. So there will come a point, boom, where, and this is about as far away from my face as I lost it. Now it's going to be very, very subtle, very subtle. If your dot is too big, you might want to, if you can't see it, you might want to make your dot smaller. But for those of you that it worked for, which dot did you look at? Okay, if I'm looking at this dot. Okay, yes, that's right. The opposite one to the eye, okay? So if you're covering your right eye, look at the right dot. So if you're using your left eye, look at the right dot. And again, bring it in very slowly, and there should come a point where that dot just, boom, is gone from the paper. And if you move your eye left or right, it comes back. Okay, so we look at this diagram right here. Do you see how the optic disc is a circular kind of region right there? And it's not right in the very middle of the eye. Okay? So this is going to be on one side of your eyeball. It's going to be closer to the middle, closer to your nose there. So if you looked at, we'll finish this thought. If you looked with your left eye and you looked at the right dot, okay? No, don't close up yet. Just listen. Let's listen. The light rays that are coming in to your eye are going to fall on the opposite side of your retina. All right? So it's going to look like this. Write this. No, you got to write this down before you leave. Okay? So here's the top version of your eyeball here. Okay? So this is the left eye. Here's your nose. Okay? Here's your other eye. I'll make this quick. You look at a dot here, right? This light ray comes into your retina. This dot over here, right, comes in, and I'll just make the line straight. But it comes in like this and falls on a spot here. So when you find your blind spot, this light that's coming in from here falls on your blind spot here, and then there's your optic nerve to your brain. Okay, so the dot, it was coming in your eye, it fell right on the optic disc. That's why you lost it. Okay, so there you go. You guys can pack up and leave. It's your lesson for today.